morning, all of you. Now we are going to deal the oxidations and reduction and the balance in the chemical equations. You know what do you mean by oxidation and what do you mean by reduction? What is the importance of this? Because if you know the oxidation and the reduction reactions, they are very helpful in balancing the chemical equations. So let us see what is meant by oxidation. So there are so many ways to define what is oxidation. First, the addition of oxygen or removal of hydrogen or addition of any electronegative element or removal of any electronegative element. What is addition of oxygen means here, sulfur dioxide. Now you are adding oxygen to become sulfur dioxide. Here the oxygen is added. We are getting sulfur dioxides. So now the oxidations of your sulfur is here it is a +4, but here it is a +6. Then so your sulfur it is oxidation. Now removal of hydrogen. Here the hydrogen sulfide gas. Here the oxidations of your sulfur is -2. Now the bromine is here used as the oxidizing agent. Now because of this, your hydrogen sulfide is converted into, or it gets oxidized to sulfur. So here the sulfur, element sulfur, its oxidation state is 0. So the removal of hydrogen is also oxidation. -2 sulfur is now gets oxidized to 0. So this is oxidation. Addition of any electronegative element. Here which is electronegative element? Here sulfur is electronegative element. Now this is your metal, so it is electropositive element. Now you are getting ferrous sulfide. Now here the oxidation of sulfide is -2. So 0 here -2. Now in this case your iron gets oxidized. Here the oxidation of iron is 0. Now it becomes +2, right? Then removal of any electronegative element. Here what is here? Which is the electronegative element here? Naturally this is your iodine. Now hydrogen peroxide reacts with potassium iodide. You are getting free iodine and 2 moles of KOH, right? So here this is a electronegative element is removed because in the potassium iodide, potassium is electropositive element and iodine is electronegative element, so it gets removed. So that this is also called oxidation. Then what is meant by reduction? Suppose in oxidation, addition of oxygen is called oxidation. Here the removal of oxygen is called reduction. Similarly, addition of hydrogen is reduction. Removal of any electronegative element is reduction. Addition of any electronegative element is reduction. Let us see, on the basis of electronic concept, the oxidation reduction can also be defined. What is oxidation on the basis of electronic concept? So oxidation is a process in which an atom or ion loses one or more electrons. Let us see these examples. Here iron is in +2 state, so it loses 1 electron, so that it becomes iron 3+, right? Now similarly the manganese 2+ here, now it gets oxidized to manganese 7+. The permanent titration, no? So manganese 2+, in that case manganese 7+ gets reduced to Mn2+. Here Mn2+ gets oxidized to Mn7+ plus with the loss of electrons, right? The reduction, that's also a process in which an atom or ion gains 1 or more electrons. The same case, right? Fe3+ gets reduced to Fe2+, and Mn7+ gets reduced to Mn2+. So on the basis of oxidation number, so how to define oxidation and reduction? Here The oxidation is a chemical change in which there is an increase in oxidation number, and reduction is a chemical change involving a decrease in oxidation number. For example, here you take our hydrogen and sulfur. Here the oxidation states of both the elements are 0 here because they are existing in elemental states. So here 0, this is also 0. Now as a result you are getting hydrogen sulfate gas. Now in this case sulfur gets reduced, and so sulfur here, what is the oxidation state of your sulfur here? 0. Now it is -2. It is -2. Hydrogen here 0. Now it becomes +1, right? +1. So it gets oxidized. It gets oxidized. So 2 hydrogens are there. So totally +2. So here -2. So it is a neutral compound, right? Charges wise they are same. So it is a neutral compound. So here your hydrogen gets oxidized, whereas your sulfur gets reduced. So this is an example for the oxidation and the reduction. We can explain the oxidation and reduction on the basis of oxidation number. Let us see what are oxidizing and reducing agents. Oxidizing agent is a substance that brings oxidation. For example, potassium permanganate, potassium dichromate. In permanganate titrations, potassium permanganate with the oxalic acid, right? It is a redox reaction because in that case reduction and oxidation are taking place simultaneously. So that is why that reaction is called redox reaction. But in that case, in that redox reactions, your manganese here, this is your potassium permanganate. Here manganese is in +7 state because this is an electropositive element. The oxygen is an electronegative element. Here +1, 4 oxygen is there. So 4 into -2, -8. So suppose they say plus X means X. Let us say the oxidation state of manganese X. Now what is X here? Because this is a neutral compound, so it should be equal to 0. So that the oxidation state of your manganese is +7. In the reaction, the manganese it becomes manganese sulfate because that reaction is taking place in sulfuric acid. So in the presence of sulfuric acid, it is converted into manganese sulfate. That means your manganese is in +2 state. So so your oxidizing agent, that is KMnO4, in this the manganese gets reduced. So the oxidizing agent itself, if it involves in a reaction, it itself gets reduced. Similarly, reducing agent is a substance which brings about a reduction. For example, hydrogen and thio, the sodium thiosulfate. These are some of the examples for reducing agents. So a substance which undergoes oxidation acts as an reducing agent, while a substance which undergoes reduction acts as an oxidizing agent. So let us see how to find out the oxidation number. Nowadays people are they are unable to, some of the people they are unable to find out what is the oxidation number. So it is very easy. Suppose if it is a neutral molecule, it should be equal to 0. Suppose if it is an ionic stage, then it should be equal to what is the ion, or what is the charge present in that. It should be equal to that charge. Let us see. Let us explain with some of the examples. Now, find out the oxidation state of manganese in potassium permanganate. I have already explained here. +1 because it is an electropositive element. Oxidation, it is electronegative elements. 4 oxygen atoms are there. So it is a neutral molecule. So it is equal to 0. So what is X? Here X is equal to +7. Right? Similarly, find out the oxidation state of sulfur in sodium thiosulfate. Sodium is an electropositive element. Oxygen, as you know, it is an electronegative element. So electronegative divalent. Sodium is electropositive monovalent, right? Electropositive monovalent. So that is why here 2 into +1 plus 2x. Suppose say the oxidation state of sulfur is X. So 2X plus 3 into minus 2 is equal to 0. So what is X here? Plus 2. So now the another one example. Find out the oxidation state of chromium in this ion. The same I mean potassium dichromate. Here there is no potassium here, so K2 instead of K2 we are having, that is 2 minus here, so Cr2O7 2 minus. Now here chromium, this is chromate ion, so here the chromium we are going to find out its oxidation state. Oxygen is electronegative element, divalent element, electronegative divalent, so 2X plus 7 into minus 2, that is here the overall charge is minus 2, so it is equal to 2 minus 2, not 0, right? So 2X plus 7 into minus 2 is equal to minus 2, hence what is X? X is equal to plus 6, right? So the chromium, the oxidation of chromium is plus 6. Remember, while expressing oxidation state you have to mention its sign also. You should not say 6. The oxidation state of this chromium is 6. Don't say like that. You should say the oxidation state of chromium is plus 6. How to balance the equation? Balance the following chemical equation: potassium dichromate, water, sulfur. The products are sulfur dioxide, KOH and chromium oxide. First, assign the oxidation number. For solving this such a chemical equation using oxidation number method, first thing is first assign the oxidation number. So, potassium dichromate, potassium is electropositive monovalent. Here chromium is electropositive hexavalent, and oxygen is electronegative divalent. So now we have assigned the oxidation number for all the elements like this. For here the sulfur is plus 4, sorry, this is element sulfur, so sulfur is 0, and this is plus 4, this is minus 2, K plus 1, O minus 2, H plus 1, chromium plus 3, and oxygen minus 2. Now you try to find out the atom which gets oxidized and try to find out the atom which gets reduced. Now here your chromium gets reduced from plus 6 to plus 3, and your sulfur gets oxidized from 0 to plus 4, right? So in order to how to balance this? Now by carefully seeing this, for every 2 potassium dichromate molecules, 3 sulfur atoms are used. 3 sulfur atoms are used, right? So 2 into plus 6 is equal to 3 into plus 4. The 2 into 6 is equal to 3 into 4, right? So now they balance the number of atoms and the charges on both sides. Now you get this equation. In this equation, the number of potassium 4, left hand side 4, right hand side also 4. Chromium, 4 chromium atoms are there. Here also 4 chromium atoms are there. 3 sulfur atoms are there. Here right hand side 3 sulfur atoms are also there, right? So how many oxygen atoms? 14 plus 2, so 16. Here 6 plus 4, 10 plus 6, 16. So in this both atoms as well as both atoms are and the charges are balanced. Here left hand side there is no charges, overall charge is 0. Right hand side also overall charges is 0 because all the atoms are neutral, right? Similarly, there is another method known as half reaction method. In this method, there are one half is oxidation half reaction and another one is reduction half reactions. So this method totally involves the combinations of oxidation half reaction and reduction half reactions. So in order to get a complete reactions, if the reaction is specified in acid medium, balance is done by adding hydronium ion like H3O plus to get the atom balance. If the reaction is specified in basic medium, balance is done by adding H2O and OH minus to get the atom balance. Let us explain with the following example. Write the balanced equations for the production of chlorine from aqueous HCl and manganese dioxide. You know the skeleton for this reaction is MnO2 Cl minus, that gives Mn2 plus Cl2. Here Mn, first the oxidation number for each atoms. Manganese plus 4, your oxygen is minus 2, chlorine minus 1. Here manganese gets reduced, so plus 2. Here it gets oxidized, so plus 0. The half reaction involved in the reduction of manganese, here the manganese exists in plus 4. Now it gets reduced to plus 2. Now balancing the charge and acid medium, here you are getting this. Now similarly, the half reactions involving the oxidation. Now that means your chloride ion gets oxidized to chlorine, right? Now here minus 1, this is 0, so it's naturally it is an oxidation. The redox reaction is manganese dioxide plus this, so manganese 2 plus here. In this reaction, why it is called redox reaction means here the oxidation and the reduction are taking place simultaneously. Here the manganese plus 4 gets reduced to plus 2 and your chloride ion minus 1 gets oxidized to 0. So here the oxidation as well as the reduction is taking place simultaneously. So this is called a redox reaction. Now balance the following reaction occurring in the basic medium. So this is an example. This is the skeleton for this reaction. Now the half reaction involving the reduction of manganese. Your manganese is in plus 7 state. Here in this manganese exists in plus 7. Here exists in plus 4 state. So the manganese oxidation number is decreased by 3 because plus 7 plus 4. So the difference is plus 3. So, and the 3 electrons are added, followed by adding OH-ion and water on the left hand side. So here. So let be the equation is number 1. The other of reactions, that means sulfur dioxide to sulfate ions. A sulfate ion into sulfate ions. Here the sulfur exists in plus 4 state, but here the sulfur exists in plus 6 state. So oxidation of sulfur is increased by 2. Hence add 2 electrons on right hand side, followed by adding OH minus ions and water to balance the reactions. So we are adding OH minus ions and water so that we are balancing the equations. Now add equation 1 and 2 by multiplying 1 by 2 and 2 by 3 and add equation 1 and 2, you are getting these equations. Now suppose if you simplify the equation, you are getting 2MnO4 minus plus 3SO3 2 minus plus water, so that you are getting this. If you count the number of atoms in the left hand side as well as in the right hand side, they are same, and the charges also, both the left hand side as well as the right hand side is same. Here in the left hand side, the number of manganese atoms is number of manganese atoms are 2 manganese atom, right hand side 2, sulfur atom 3, here also 3, and oxygen atoms 2 into 4 8 plus 9 plus 1, so 18. So 18 on left hand side. What about right hand side? The number of oxygen atoms 4 plus 2 plus 12. So 6, so 18. So totally 18 oxygen atoms both in the left hand side as well as in the right hand side. What about the charges? In left hand side, here 2 minus, here 3 into 2 minus, so 6 minus, here 2 minus, so 8 minus. What about here? Here also 2 into minus 1, so minus 2, 3 into minus 6, so 8, so 8 minus. So charges both in the left hand side as well as right hand side are same. So this is the balanced equations. Why? Because both the atoms as well as the charges are balanced. Thank you.